Alkali metals are metals in group 1, which include lithium, sodium, potassium, rubidium, cesium, and francium. Hydrogen is in the same group, but isn't an alkali metal, because hydrogen is not a metal and has different properties from the rest. Alkali metals have one valence electron, which means that they need to lose one, so they have a full outer electron shell. Their reactivity will increase as you go down the order. Alkali metal will always be found mixed with other elements because it will react immediately to the air if exposed. Although they are different from usual metals, they have some common properties such as being lustrous, good conductors, but you can't see the luster unless you cut them because the exposed alkali metal will create an oxidizing coating on it. They're very soft and must be kept in oil or it will react with the water vapor in the air and cause them to catch fire. This will not happen in the case of rubidium, cesium, and francium because they would actually explode. Alkali metals will only form ionic bonds because they can't share electrons with another element. Since it has only one electron, the electron will transfer to the other element rather than sharing it, which turns the atom into a positive ion. They're called alkali metal because when they react with water, the water will turn into alkaline with pH value more than 7. Halogens are nonmetals in group 17, which include fluorine, chlorine, bromine, iodine, and acetine. They're also very reactive because they only need one more electron to have a full outer shell. They're named halogen because the term halogen means salt former, and compounds containing halogens are called salt. Like alkali metal, they're not usually found independently in the nature because of their reactivity, but unlike alkali metal, as you go down the order, the reactivity decreases. Elements in halogen are nonmetals, so they're not always solid at room temperature. For example, fluorine is a gas at room temperature, iodine is a solid at room temperature, and bromine is a liquid at room temperature. This makes halogens unique, the only group that has elements in all 3 states of matter at room temperature. The color of the elements are also darker as you go down the group. Fluorine is pale yellow, chlorine is yellow-green, and bromine is red-brown. Iodine crystal is shiny purple, but turns dark purple easily when heated. When forming compounds, halogens from both covalent and ionic bonds by either getting an electron to form ionic bonds with another metal or sharing electrons to form a covalent bond with another element. The compound being an ionic or covalent bond depends on electronegativity.
Now that we explained to you what are alkali metals and halogens, we will now explain some of the uses we have for them. Although these 2 groups are quite hazardous, when they are pure, we use them in many things in our daily lives.
Lithium is used in an item that we see in our everyday life, glass. Lithium is added to glass and ceramics to make the material stronger. An example of an important lithium compound is lithium citrate. It is added to petroleum to make a thick lubricating grease. This grease is used in industries such as military and automotive because it doesn't break down at high temperature. It doesn't even harden when cooled. It doesn't react with water nor oxygen in the air. Sodium is used in street lights because it produces brilliant yellow light. It also has many useful compounds such as table salt and baking soda.
Potassium alone is not useful, but it creates many important compounds such as potassium chloride and potassium hydroxide. Potassium chloride is used in fertilizer, salt substitute, and used to produce other chemicals. Potassium hydroxide is used for soap, cleaning detergent, and drain cleaner.
Rubidium is used in vacuum tubes as a getter. Getter combines and removes the traces of gas in it and photocells. Cesium is also used as a getter. It is also used in atomic clocks, photoelectric cells, and as a catalyst for the hydrogenation of several organic compounds. Francium, on the other hand, is only used for scientific research because it has a very, very short lifetime. Now let's look at the uses for halogens. Fluorine by itself, it is a toxic, but its compound sodium fluoride is used in toothpaste and drinking water to prevent dental problems. Another one of its compounds is hydrofluoric acid, and that can be used to dissolve glass as well as etch light bulbs and other products. Chlorine is similar to fluorine because chlorine is also a toxic gas at room temperature because it is opposite of toxic. It is also used to make antiseptics that are used to make drinking water safe and cure swimming pools. Large amount of it is also used in production of paper products medicine, and plastic, just to name a few. A major use of bromine is to purify water. Compounds treated with bromine are used to treat water in swimming pools and hot tubs. Iodine can be used to kill fungus, bacteria, and other microorganisms, such as amebas. Potassium iodide is also used to treat effects of a radioactive accident. Iodine is also used to test if food contains starch.
An isotope of astine called astine 221 is also used to trace radiation as well as to cure cancer.
Alkali metals are the first group on the periodic table, and fluorine is the 17th group. While alkali metals can only form ionic bonds, halogens can form either ionic or covalent bonds. They are the most reactive on the periodic table. The main difference in terms of their properties is that alkali metal has many properties that other metals have, such as being lustrous and good conductors. And they're always solid at room temperature. Halogens has elements at all three states of room temperature, such as solid, liquid, and gas. And the ones that are gas at room temperature are poisonous. Despite alkali metal being hazardous and halogen being unpredictable, elements from both groups are used in many of our daily lives.